Hello, fellow chemists. Jolly here. This discussion is going to be on chemical bonding, just the basics, and then I'm going to talk about the pieces in individual lectures. Okay, well, what is a chemical bond and what are the types of chemical bond? Now, there's two types that answer both of those questions. So the first one is called an ionic bond. An ionic bond is when the electrons are transferred from atom to atom. And it creates ions. Okay, what kind of ions are there? Well, there's two. There are cations, which are positive, and there are anions, which are negative. All right, what is the other type of bond? It is called a covalent bond. And that is sharing of electrons. And there is no overall charge for each piece because they are perfectly being shared. And those also can be represented, not with positives and negatives, but they can be represented with a pictorial version called a Lewis structure. Or sometimes it's also called a Kekulé structure, but Lewis is more well known. So we have our ionic bonds, we have our covalent bonds. Now these two together are what is known as an intra molecular attraction, an intramolecular attraction. So let's take a brief look at both an ionic bond and a covalent bond, and then we'll go into details in future little videos. All right, now an ionic bond, let's take sodium chloride, for example. So I have sodium, which is a positive, and I've got chloride, which is a negative. And there's a very, 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 very important thing. Nature loves neutral. So when you put two ions together, it doesn't matter how many there are, but you need to make sure that they overall cancel each other out because nature loves neutral. And so usually I don't draw these wonderful little charges. I would just say sodium chloride. Now, covalent bonds, on the other hand, those don't have ions, so we're going to draw some lines to represent bonds. And because I am an organic chemist, of course, I'm going to draw a carbon. Now, in a Lewis structure, we draw these lines to represent the bonds, and every line represents two electrons. If it is a single bond, it's only two. If there's 4 electrons, oops, I was going to change that color, but that's okay. 4 electrons implies a double bond, which is 2 lines. And then it's not shown here, but you could actually draw 3 lines and it would be the triple bond. But that's as big as you get. And then I have these little electrons right here. If they're not part of a bond, we call those lone pairs of electrons. That's a lone pair, and this oxygen happens to have 2 lone pairs. And that is the basic idea behind covalent bonding. And depending on the identity, you can either have, running out of room here, we can either have, if they have equal sharing, that would be called a nonpolar, or if they don't, it would be called polar. They share equally. And they, oh, and I just did that backwards. Polar bonds, they do not share equally. And in nonpolar, they share equally. So we can take a look now at that is based on electronegativity, which again will be talked about in a different video. But to give you a flavor right here, carbon and oxygen, they're different. So this one would be considered polar. Now carbon and hydrogen, they are different, but they're awfully similar to each other. So it depends on who you're talking about this. Technically, this one is also polar, but not by much. So in the organic world, we tend to call it a non-polar bond. But by the basic definition, that would also be considered a polar bond. And again, when we get into the Lewis structures, we will deal more with polar and nonpolar. But that is chemical bonding basics in a nutshell. Until next time, Jolly out.